Hello everyone, Assalamualaikum, welcome back. We are now at the last part of the video for trigonometric functions. So we are now going to sketch tangent graph. This is the basic graph for tangent. So let's have a look at this concrete example number 5. Sketch y is equals to -2 tangent x. And this is quite simple. It is just that there is a negative sign here. And then we need to state its domain and range. So step 1, so this one is a bit different. It's not that much different. It's just a 3-step, a very simpler steps. There are only 3 steps, much more shorter, but it's almost the same. It's just that at the third step is a bit different. We will find the vertical asymptote because in tangent graph, there is an asymptote. We call this vertical asymptote, whereby the graph cannot go across the asymptote. They cannot go across the dotted line. They can just go up and up and up and or down and down. That's it. Okay, so let's just move forward to the first step, which is the period length. There is no amplitude here because the graph is going down, below, or up, above. So there is no amplitude at all for the tangent graph. Remember that. There is no amplitude. So here goes the period length as the first step. So here goes the first step, the period length, which is pi. And right now, this is just pi, not 2 pi. Remember, this is single pi. Okay, coefficient 1, single pi divided with the modulus b. So in this case, our b is, by this time, by this video, I think you already understand that the b is just 1. Therefore, it is just pi. And then the phase shifting is bx plus c. In this case, your linear is just x. This is your linear. And the problem here is only x. In the bracket, the linear is only x. In this case, kalau you nak tahu, this is x plus 0 lah. There is no c. This is just x plus 0 equals to 0. Therefore, x is still a 0. So it doesn't shift to anywhere. It just remain there. Okay, it doesn't shift to left or right. No shifting. So that's it. Step 3, vertical asymptote, or I short form it as VA, vertical asymptote. So vertical asymptote, you just take the linear in between here. The linear is just x, and then you put the formula. The formula must be in between. Yeah, you must just follow the formula. The formula said that the basic shape is in between, the one cycle is in between negative pi over 2 until positive pi over 2. You just use the formula and don't argue with it. Just use it, write it down there here. So there you go. Your x in one cycle, your x is in between negative pi and positive, negative pi over 2 and positive pi over 2, whereby they are both not inclusive. Yeah, they are not inclusive. They are open bracket. There is no equal because this is a dotted line. Dotted line means it is not inclusive. The dotted line, the asymptote seems very obvious already. Asymptote means the graph cannot go across the dotted line. So that's why it's open bracket. It's not closed lah. So you understand that already. You can now go to sketching part, which is, here is my frame of the sketching. As you all know my style, I love to do this gate first. The dotted line here is very important for me. So basically this is typo, sorry. This should be pi over 2 and pi, negative pi over 2 and positive pi over 2. This is my gate. Remember, you must draw your gate first. Okay, this is your gate. And this is the beginning of the gate, and this is the end of the gate, the smallest to the biggest. Okay, you draw the gate first, and then you label everything: x-axis, y-axis. Please do that, don't skip that thing. Okay, this is your x-axis, and then this is your y-axis, and then you will never see me forget to put down my function. My graph function is negative tangent. These two, walaupun rasa macam amplitude lah kan, tapi tangent tiada amplitude. So you can ignore the value of 2 there. You no need to be afraid of it. Whatever the value, it doesn't affect our graph. Okay, it doesn't affect at all. So yang penting you tahu dia negative tan. Negative tan macam mana bentuk dia? Negative tan is from left curve like this and then going down to the right hand side. So that is our shape. So basically we know that it is just going to go to the origin, but there is no shifting. You can refer that this is the shifting. No shifting. It means that dia memang dekat kosong, origin. Dia lalu kosong ni. And then there you go. This is from the negative part to the positive part. That's it. That's your graph. The end of story. Very easy. So this is the negative tan, negative 2 tangent x. Remember, yeah, it doesn't matter whatever the amplitude is. It doesn't affect your graph. As long as you know it go through the zero because there is no shifting, it means it's just the same anyway from the basic graph like that. Yeah, you can see here this is positive 1, negative 1, but positive a. A is 1, I meant. Yeah, the shape is still the same anyway. And all you gotta do is that you must know how to write your domain and range right now. So let's learn how to write the domain. So if you look here very closely, there is a formula for the domain. Let me just copy this down. So I want you to know that this is a formula that we can know how to write the domain because the domain is a bit difficult to write. So you listen here carefully. X is not equal, bermaksud X is anywhere else. Okay, X itu berada, X itu, the domain kan. X, domain bermaksud X lah, betul tak? So the graph is everywhere. The graph is actually everywhere except, ni maksudnya except lah. Yang kita nak tulis ni yang except. Except apa? Except di mana X is not equal to the n times with the period. In this case, the period is what? The period is pi. Just follow your step 1, the pi, it said here pi. So you write down here pi. So n times pi. And then plus with what? Plus with vertical asymptote. Dia kata vertical asymptote yang mana? Ada dua ni madam, ada dua dekat sini. Kan kita tulis dua kan? So here goes, this is, both of these are vertical asymptote, but which one do we choose? So make sure you choose the positive vertical asymptote in the formula. In formula, you choose positive. Choose the positive one, which is pi over 2. So whereby the n is not equals, where n is in the element of integer. Okay, so you nak kepastian, you masukkanlah n. N adalah in between any numbers from -1, 0 to 2. N is, what do you call it? Integer, right? Integer cannot be 1/2, cannot. Dia nombor bulat tapi yang ada negatif lah kan. So you just try masuk when n is equals to 0. What is your x value? Yang asymptote ni lah. X is not equal means it's asymptote. So when you sub in the value, you will get x is not equals to pi over 2. So pi over 2 is there. This is your n equals to, just now, berapa tadi? Your n is equals to 0. So here we go. N is equals to 0. Di mana this is the asymptote. Yang pertama, pi over 2. The asymptote is pi over 2. You have done it. And then you can try to calculate n is equals to -1 maybe. So you try -1, you will get negative pi. And then plus with pi over 2. You try calculate it. And you will get, what is this? You will get negative 2 over 2. Negative pi over 2. So basically at this asymptote negative pi over 2, this is actually you are using n equals to -1. So basically that's it. In one cycle you use two different value of n, which is n is equals to 0 and n is equals to -1, betul tak? So ini adalah pintu asymptote kita lah. Asymptote kita memang wajib kita lukis untuk tangent. So basically this is the this is the domain lah. So basically my topic right now is trying to tell you that the graph is everywhere around inside of this vertical asymptote. The graph, the x is everywhere around here except, okay, this is the word except bermaksud not equal lah, except at this place lah, where there is the asymptote that the graph cannot go across the asymptote. The graph is only inside of this asymptote but not outside of the asymptote. Macam itulah jalan cerita dia. So there are another more graph besides here. Okay, so dia panjang. So that's why lah kita letak n is in the element of integer, sebab it could be -2, -3, or +2, +3, you know. The n is huge numbers, you know. That's why we must put like that. Okay, and then at the end here is the range. The range is just -infinity until infinity, because you know there is no amplitude for the tangent graph. Hujung atas, hujung bawah, you know. You can see very clearly that hujung atas, hujung bawah, tak ada penghujungnya. Memang hujung-hujung ni infinity sahaja. So that's the range. The range is always like that for tangent punya graph. Cumanya domain sahajalah yang agak critical. Cara domain ni you kena tulis hati-hati sikit lah untuk tangent. So that is the answer. Let's move to the next example. This is my last example for you all, and the rest of it you can do it exercises in your tutorial book. So the last example from me is example 6. Sketch y is equals to tangent 2x plus pi over 2. So remember, in our syllabus, there is only linear in the bracket, okay? Why do I keep saying that? Because there are cubic, there are quadratic inside of this bracket, but we do not learn it. We only learn in our syllabus, we only learn inside of the bracket, it's just a linear graph. So we have now reached to the tangent, so let's draw it. Okay, so first step is there is no amplitude, but there is a period length. Go to the next step, which is gonna start from pi over b, yeah? Pi over modulus of b. So pi over modulus of b, which is pi over 2, which we will get a period length of pi over 2 lah. So that is our period. Okay, now that is the period length. And then the phase shift, the shifting right now is 2x plus pi over 2 is equals to 0. Therefore, your x is equals to pi over 4. Is it right? Negative pi over 4, sorry. It's shifting a bit. Negative pi over 4. Yeah, there we go. That is our answer. So if I got a negative, it means that we know it's shifting to the left. Yeah, that's how we know. When we know the sign here, we actually know it's shifting left or right. So it's a bonus to us. We know that it shifted to the left from the original part. Original kan. Pada asalnya dia kat kosong, tapi bila kita tahu dia negatif, bermaksud dia ada shifting sedikit ke arah kiri. Sebanyak berapa unit? Sebanyak pi per 4 unit. So last step is vertical asymptote, ataupun saya sebut dia sebagai VA. So here we go. You must put down your linear in the middle here, and in between negative pi over 2 as usual. This is a formula, we just must follow it. You don't argue with it. Okay, and then you make 2x as a subject. You will get, here goes, you will get here pi. No. Here goes, you will get here 0. And here goes, you will get here negative pi, isn't it? Yeah, you will get negative pi. And in the end, you want only one cycle, which is x is in between negative pi over 2 and 0. That is what you get. Okay, x is in between negative pi over 2 and 0. So that is your cycle. So here you go. You can see me as usual. I have written down my axis, x-axis, y-axis. You can look here very carefully. I have done this. x-axis, y-axis, and also my pintu penting. You know, you can see here my pintu, my first pintu is negative pi over 2, and then my second pintu is 0. The dotted line, that's what I'm saying. So this is actually the vertical asymptote, two vertical asymptote. That's very important to lukis dulu, because after you lukis the dotted line, you can now refer your basic shape. The basic shape for positive tangent is just like this. Stop. And like that. Done. So you are almost finished. You just need to draw it. So again, I just put a short line here. So this is my first graph. I mean, half of the tangent graph, and here goes the full of the tangent graph. Ta-da! Done. So in one cycle, I just draw one cycle. Kalau nak cari lebih daripada satu cycle, boleh. Belajar sendiri. Macam mana nak cari another cycle. Okay. But as long as you know right now that we need to find the intercept. Okay. Kita kena cari intercept dia. So intercept dia macam mana ni sekarang? Can I just shift it a bit to the left, to the right here? Yeah. So how can you figure out that what is the intercept? Intercept dia apa? So basically you can look at your ini. What do you call this? This is shifting, right? So it shifts to the left sebanyak negative pi over 4 unit. So basically that is the answer. Sebenarnya daripada sini dah terus tahu bahawa ini adalah bernilai negative pi over 4. Dia shift from 0 because originally it's at 0, isn't it? And then it says here it shift to the left sebanyak pi per 4 unit. Negative sign tu bermasuk ke kiri. So it shift to the left now, and so that's it. That's the graph then. You dah cari intercept, dah settle. And jangan lupa untuk label. Very easy if you know the shifting things. And then the final part is where you just write down its domain. So basically secara penuhnya lah, sebenarnya secara lengkapnya kita letak curly bracket begini. X is in everywhere. X is everywhere. Actually, X is everywhere. Sebenarnya macam ni kita kena tulis secara penuhnya. X is everywhere except X is not equal. Ini not equal bermaksud except lah. X is everywhere sebab graf kita ada banyak tau. Graf kita bukan sikit je. Graf ni banyak. So dia berada di semua tempat kecuali pada asymptote. Kecuali di asymptote masing-masing lah. So X is in everywhere except n times it with its period length. Times it with the period length. N times it with the period length. You just use the formula that I've given you. You don't need to pening-pening fikir kenapa. Just use it. And then plus it with the vertical asymptote yang positive, okay? Take the positive one. Positive asymptote. Take that one. Jangan ambil yang negative. Ambil yang positive asymptote. Okay? And that's it. That is your answer. And then jangan lupa tak siap lagi. Where n is integer lah. N is in the element of integer, and then you tutup curly bracket. That is your domain. It means that the graph is everywhere, kiri ke kanan, kanan ke kiri. It's everywhere except that there is a vertical asymptote around here. Tak percaya, masukkanlah setiap satu nilai n dan you tahu asymptote dia apa. And then the range, final part from me, where the range we know that it is from infinity, negative infinity to infinity, dari bawah sampai atas, and then that's it. That's the end of the classes. The end of our video, which means that if you know one cycle, if you really know how to draw one cycle, I think I have no problem in letting you to think the rest of the graph lah. You boleh fikir the next of the cycle sendiri. Tapi ini termasuk tau. Maybe I should delete this part. Yeah. Just make sure that you find your own asymptote dulu. You cari asymptote dulu, barulah you pandai lukis sebenarnya. So you letak asymptote dulu, barulah you boleh lukis dengan cantik dan jelas. You get what I meant? Okay, therefore I stop here. I wish you good luck in finding the answer for other kind of problem from the tutorial. Thank you.